This is chapter 4, number 7. So I've already written down the basics. I drew the picture of the particle and I have the velocity and acceleration listed. The first part of the problem asks me to define the vector velocity of the particle as a function of time. So velocity equals the integration of acceleration times dt. Now this comes from the fact that if you take the derivative of velocity, you get acceleration. So if you were to go backwards, the integration of acceleration would get you velocity. So if you solve this out, this would be now using the power rule, you would go, but going backwards, you would get 4t to the 3.5 power j hat meters per second. But this isn't the final answer, because you have to keep in mind that you had the 5 I hat in the beginning. So your full answer would technically be 5 I hat meters per second plus 4t to the 3.5 j meters per second. For part B, you're asked to determine the position of the particle as a function of time. So x equals the integration of vt dt. Now this comes from the fact that if you take the derivative of position, you get velocity. So once again, you're working backwards. So this would eventually turn into 5 I hat meters per second dt. So you would get 5 I meters per second t. But then you also have to remember that you also had acceleration in the beginning. And then with that acceleration, you found the velocity. So the second part, you have velocity equals 4t, 3.5 j hat. And you'll do the same thing like you did in here. So then, in total, your position would be 5 I hat t plus 1.6 t 5.5 j hat and that's your answer.